In this video, I'm going to talk about some basic concepts of random variables and probability distributions. Random variables and probability distributions are some terminologies used to describe randomness in mathematics. Let's take a look at this situation. Suppose the gross profit of selling a watch is $20 and the fixed operating cost of each day is $30. We let X be the number of watches sold each day and Y be the daily profit. Then Y can be expressed in terms of X like this. We have learned that X and Y are known as variables in mathematics. By referring them as variables, it means that they are not constants. So these unknown numbers can have more than one possible value. Suppose the possible values of the variable X are 0, 1, and 2. If we know that the occurrence of these events can be described by probabilities like this, then we will further describe these unknowns as random variables. Because from the probabilities, we know that these variables have a nature of randomness. If a variable is a random variable, mathematically it is usually denoted by a capital letter like this. In this situation, we can further describe the random variables as discrete random variables, because the possible values are not continuous in nature. That means we know that X can be 1, X can be 2, but it cannot be 1.5. So we describe X as a discrete random variable. There is another type of random variables called the continuous random variables. But in the scope of M1, we are only interested in the discrete cases. Mathematically, we usually use this notation, P capital X equals small x, to denote the probability function of the random variable X. Here, capital X means the random variable, and small x means a possible value of capital X. In a probability function, the input value is a possible value of capital X, and the output value is the value of the probability of the event capital X equals small x. For any probability function of a discrete random variable, it must have the following properties. Firstly, because the value of the function is a probability, so this value must be between 0 and 1, and it is possible that this value is exactly equal to 0 or 1. Secondly, the sum of the probabilities of all the possible events must be equal to 1. This looks trivial, but it is an important consideration when we are asked to determine whether a function can be a probability function. By knowing the exact probabilities for all possible cases involving the random variable X, we essentially know the probability distribution of the random variable X. There are many ways to represent a probability distribution. For example, besides writing down each probabilities explicitly like this, we may use a table, a graph, or even a mathematical formula if there is a mathematical pattern among the probabilities. Finally, let's take a look at this example and see how we can describe randomness with random variables. In this example, we need to randomly select 3 pieces of fruit from 6 oranges and 4 apples. We let capital X be the number of oranges selected, and this capital X is then a random variable. In A1, we need to represent the probability distribution of X by a formula. That means we just need to calculate the probability of this general event capital X equals small x. Then we can get that P capital X equals small x is equal to 6cx times 4c3 minus x over 120. And that's the probability distribution of capital X. Please pay attention that in order to specify the probability distribution, we must specify all the possible values of the random variable X. In this case, we can specify that X is equal to 0, 1, 2, or 3 like this. After obtaining this probability formula, in A2, it is very straightforward to represent this probability distribution by a table. We simply need to calculate the value of this expression for each value of X, and then construct a table like this. Once we have this table, the probability distribution of X is very clear. And then we can deal with part B easily. In B1, to find the probability that x is greater than or equal to 2 and x is smaller than or equal to 3, because x is discrete, that means not continuous, so we know that x can only be 2 or 3 in this event of x between 2 and 3. And therefore, by the addition law of probability, the required probability is equal to 2 over 3. In B2, to find the probability that x is smaller than 1, similarly, we know that x can only be 0, so the required probability is then equal to 1 over 30. This is how we can understand the basic concepts of random variables and probability distributions.